Okay team, let's finish this one off. We've got about 10 slides to go. So our site plan, when we're deciding our wiring layout and cable routes, we must consult related drawings. So there may be times where our drawings will specify where cables are to go, and there may be a reason for that. An example might be segregation of services and that sort of stuff. So we need to follow that. We consider the building construction as well as the internal layout of other services such as plumbing, waste pipes, air conditioning ducts. A couple of things there. One would be isolation of services, not putting them on top of each other. That may or may not be a big issue. But we would need to think about access later. Air conditioning ducts is a good example where if we've got big air conditioning ducts in the roof, you may not be able to get into that ceiling space. And if you've got cables running through there and you'll need to get access to them later, that could be a problem for you. Next point there, check for availability of any ducts or wells provided in the building structure that can be used. Oh look, I've got a highlighter. How cool is that? I'm not sure what to do with this. Okay. So we check for the availability of any ducts or wells provided in the building structure that could be used for electrical purposes. In some cases there may be duct. If we're talking about a big building, there will be ducts provided. We will have some sort of system inside the building for the purpose of cables. In a large multi-story building, for example, you'll generally have a service, what do they call it, a service duct, which may even be like something that you can walk inside. It would look like a walk-in wardrobe on each level, and it will have the ability to run cables and pipe work from one floor to the other. If those things exist, then obviously we should be using them. Consulting the site plan when considering the route of supply service line. So our cable coming into the building, we need to think about where what other things are there. At the very least, we want to avoid areas where other people are going to dig later. So we probably want to be away from sewer lines, water lines, drains, that kind of stuff. Because if the plumber comes along and digs it up later, and we know that plumbers aren't smart, let's be honest. They're going to dig up our cable, they're going to chew the ends, they're going to die. So we want to make sure that our stuff is well away from everybody else's. And if the site is not level, then that's something we need to think about. As it says there, especially where ground clearance under area cables would be a consideration. If the site is on a hill, then the distance from the ground to your cable may not be the same from the start to the finish. I wish I could. There must be a way to. Must be a way to delete my highlighter, I guess. I don't know. Never mind. So this is a site plan, an example of a site plan here. What is it telling us? Position of main switchboard, distribution switchboard, where the submains are and the proximate route. It's generally telling us an indication of interconnection rather than the physical position of the wiring. So, yeah. What it's saying there is, for example, we can see this red line here, which is our submains going from one distribution board to another, which is nice, but that's not necessarily where that cable is. This is actually a picture of a service station. You can see there we've got a car wash, a dispenser island and canopy, tanks over here. What else have we got? There's our mains cable coming in from the street. So I could tell you from my experience that what we'd be looking for, if we needed to find this cable, the submains here, we'd be looking for an as-built drawing. An as-built drawing is something that you draw after. So you have your site plan. Site plan is something you have before. As-built drawing you draw afterwards, and that's similar to the site plan, but it shows what you actually did as opposed to what you planned to do, because sometimes you might end up running the cables in a different place. So in this example we'd be looking for an as-built drawing, and the as-built drawing should show us exactly where those things are. Although, as a little aside, I don't know if little stories are going to be as effective in this format as they are when I'm standing in front of the class, but never mind, let's see. So as an aside, I can remember an example where I had a drawing like this. It was an as-built. It showed from one end of the service station to the other a duct that was running, and I needed to get a cable through there. So I found each end of the duct, underground duct, a 4-inch pipe. I found each end of the duct, and it was about 50, maybe longer, meters that I needed to run this cable, and I spent about 2 days trying to get a cable through this thing, and I just could not from either end, not with every method I tried, nothing. Eventually we gave up, and I decided we would just dig it up. And when we started digging, we found that the dickheads who had done the installation saw on the site plan that they needed to run that 50-meter duct, but they figured that no one would never know the difference, so they just ran about 2 meters of ducting from each end. So it looked like there was a duct there, but actually there was nothing in the middle, and they probably saved themselves, I don't know, a few $100 worth of pipe. So don't be like that, Jesus. And if you're gonna do shit like that, put it on your as-built drawing, because then somebody's going to come later will appreciate that you actually wrote on there that you didn't fucking do it. Excuse my language. I probably shouldn't swear in this format because it's recorded, unlike our normal classes where I could just deny it. If you told on me, I'd just lie. Now there's a record of what I'm saying, so apologies for the swear words. I'll try not to do that. Alright, standard labelling conventions. So use component designators. This is automatic with any software program, but we still often see schematics without them. If you draw your schematic on a napkin and then scan it, make sure to add component designators. These make the circuit much easier to discuss. It is difficult to deal with questions or queries where schematics have component designators like the second 10k resistor from the left by the top push button. It's a lot easier to say R1, R5, Q7, etc. So this goes back to what I was saying before about the coils. I said we would use a K for a coil, and I put a K1 next to the coil and then a K1 next to the contactor or next to the contact that coil controls, so on and so forth. So labelling each of your things, R1, R2, as it says in here. In this case, our R's are going to be resistors, and I think Q's are capacitors, maybe. Can't really remember. Clean up text placement. Programs insert part names and values based on generic part definition. This means that they often end up in inconvenient places in the schematic when other parts are placed nearby. Fix it. Those can be placed in at least 4 orientations since they have direction too. Placement of text around a part, like the component designator and value, probably won't work in other orientations than it was originally drawn in. If you rotate the stock part, move the text around afterwards so it's easily readable, clearly belongs to that part, doesn't collide with other parts of the drawing. Vertical text looks stupid, it makes the schematic hard to read. Alright, whoever's wrote that one obviously has some pretty clear views on how we should be doing this stuff. If you haven't worked out already, we're talking about computer-aided drawing here, our CAD programs. I don't know if we have one at MIT for you guys to use. Obviously it's not a thing at the moment, we can't do that, but maybe when we're back I'll have a look at whether we have any access to CAD stuff. But these are just some general points to note for if you are creating CAD drawings. Basic layout and flow. In general, it's good to put higher voltages towards the top, lower voltages towards the bottom, and logical flow left to right. So logical flow left to right would be like our input comes in on the left, and then we have our components as they are electrically. That's how we draw them physically, and then our final output would be on the right, or our last appliance or whatever. That may not be possible at all times, but at least a general high level effort to do that will greatly illuminate the circuit to those who are reading the schematic. Power connections should go up to positive voltages and down to negative voltages. direct connections within reason. Spend some time with placement, reducing wire crossings. So that means that every time you draw a picture, you are going to, or draw a circuit diagram or some sort of electrical diagram, you're going to have times when wires that are not connected together in real life, the lines that represent them will cross each other in a drawing. Now there are ways that we write that to indicate two lines that are crossing that are joined and two lines that are crossing that are unjoined. But if you think about it, I don't want to look at a drawing and see lots of crossed lines that are not joined cables, because it will confuse the hell out of me. So if we think about the way we place our components to avoid having as many crossed lines as possible, or avoiding as many crossed lines as possible, this is going to make your drawing easier to look at and easier to read. Reading and interpreting electrical drawings is a skill, and sometimes it's quite difficult. I can probably work out most circuits, but sometimes you look at a circuit diagram and just think, I've got no idea what's going on here. You know, you might spend days poring through a diagram trying to figure out what it means. Yeah, you all can read the rest of that yourself. Ooh. Design for regular size paper. Yeah, that's a good point. A3 is pretty common. A3 is pretty common for big electrical site plans and that sort of thing. But don't design your drawings to be printed on an A2 or something, unless it's if you're going to do that, draw it and then print it yourself and distribute those drawings. You put it on whatever size paper you want. Keep your names reasonably short. Just because software lets you enter 32 or 64 character names doesn't mean you should use them. It's a good idea. Make sure we have a legend. Even if you're using standard symbols, it's a good idea to write in there, especially the common ones that you're using, what they mean. It just makes life easier for everybody, right? And end of slideshow. Do I want to keep my ink annotations? No. Okay, from here, now that you've finished the slideshow, well done. I'm going to open up the test. Once I've uploaded all of these, I'll open up the test probably later on this afternoon, so you guys are able to do it. I will put a code on that test, and I'm going to put the code will be 898. 898. You might want to write that down. 898. The reason I'm going to do that is so that I know that you're watching these videos. One, because we need to do more than just read slideshows and do tests. As I said yesterday, a lot of what we're going to have to focus on over the next few weeks is how do you guys really emphasize your learning and make sure that you are learning, not just copying stuff and doing tests. When we get back to school, we will do an exam on this module, and that will be closed book, and it will be a pass or fail. So you are going to need to learn this stuff. I would recommend that you do whatever you need to do to make sure that happens. So one thing I will do is I'm going to put codes on the test, and I'm going to tell you what the codes are during these videos so that I know that at least you're watching them. The second reason for doing that, making sure you're watching them, is, Jesus, can you imagine how stupid it would be if I sit here and go through this and talk to myself? I'm sitting here looking at a computer screen, talking to myself as if I have an audience, and then only to find out later that none of you guys watched any of this. So I'm going to put the codes in the videos, and I'm not going to put them all at the end either. So if you thought you were clever and you just scan to the end of each video to hear the code, bad luck, I'll stick them somewhere else in the next one. So that is the end of this module. Feel free to give me a bell if you need any help or anything like that. I will probably start the next video tomorrow, maybe this afternoon if I'm bored, and at some stage I'll put together a little video where we run through the practical book and have a look at what you guys would be expected to do there. As I said, any queries, anything at all, I guess I'm still working, so even though you're not in front of me and I'm not at school, I'm not at tech, just flick me a message on Facebook, email, whatever you like. I mean, you could call me if you want to, but I don't really want to have to talk to you. But call me if you need to. Yeah, any dramas, let me know. Thank you.